Because I'm the man. That's going to get recorded.
Do you want me to talk
So did that.
Just so you could hear, so we would be able to hear that.
It's really an ego thing. All right, so let's see. We got this Ferris wheel, and we were all able to identify that height as a function of time, right? Let's see, and the intervals were like 5, 10, 15, 20, correct? And it went on from there, 25, right?
Yes.
So far, so good. And it looks like it went up and then went back down. And my graph is not, in fact, the graph's a disaster. I'm going to regraph it here.
You want it from Grapher?
Look, I know I can get it from Grapher. And we're at the midline here, and then we're back down, and then we go back up. So we see this graph, right? And we notice the changing concavity, right? So it's concave up, basically along these sections, right? And it's concave down along these intervals. And from a recycle extra and sort of diving back into our brains, we know that this type of function resembles what type of function? A sine wave, right? And we can bring in a little grapher window here. And we can just graph sine of x, enter, and there's our sine wave, right? It is pretty, it's nice. Here's a question. What is the unit for like what you're taking the sine of here? Is it in degrees or Zavi, what are we in? How do you know?
Well, basically, if you look at the graph, you see on the x-axis we have whole numbers. We have, well, that's the forward. I don't think the recording device.
No, keep talking. So Zavi's saying that we have a certain axis.
For example, can you go back to the graph?
Here we are.
What we have is, we have 0, 0, which is a point that we would have on the sine graph in degrees, but then we go a little bit, we increase the x value on the x-axis, and we have 0 and what would be around pi.
Oh, okay, interesting. So this is
as opposed to 108. One is representative.
roughly pi.
Right, and then we go down, and that kind of looks roughly like.
Yeah, 6 and change, right? So indeed, this is 2 pi. Nice. Which, of course, this, be excited, right? This should come from the fact that, right, it's intuitive, and it relates to what Zavi was saying, right? If we were an angle, if x were, of course, the angle opening on a unit circle, right, we would have a sine of 0 at x equals 0, x equals pi, right? Because that'd be like, right, our sine of pi, right, that's pi, our sine of pi is 0, and our sine at 2 pi, sine is also 0, right, 2 pi equals 0. And in fact, it's made its way all the way around the circle. It's made its way completely around one oscillation, if you will, in 2 pi, right?
Yeah.
Anybody know what we call this length? The amount of time, if you will, that it takes to complete one full oscillation?
The amount of time?
The amount of time or the amount of x. What do we call that? Do we call that? Yeah. The period. We call this the period of a trig function, of a sine or a cosine or whatever function. And it's in this case,
What is the definition?
2 pi. The period is the amount of x, right, that it takes to complete one full kind of rotation or oscillation or whatever, right? So
How long before it repeats?
yeah, how long before it repeats itself? That's even better.
How long
Yeah.
the
So
graph?
period, time, or x it takes for a function to repeat itself. Groovy. Okay, so we recognize that this is a sine function, but it's different, right? We can see that this is clearly different from this right here, especially when, right, remember this is at 250 and this is at 500, correct? Yeah. So we have to use the same like rules of transformations, of function transformations, to get ourselves from this function to this function. And I'm wondering, maybe we can talk about transforming, right, from the y equals sine x to, right, really we want to get from y equals sine of x to the Ferris wheel. And we're saying not just really that y equals sine x, but in fact, right, we're kind of saying f of x equals sine of x. So I'm curious, there are a number of transformations, right? A lot of different things are happening. I'm wondering, where did somebody start? Where did somebody start? What's sort of the first transformation they performed to f of x to sort of get us going from our basic y equals sine x toward the Ferris wheel function? Yeah, Alex.
Well, the first thing that our table did was add 1 to the result, or to the y.
Nice. So what type of transformation, Alex, would that be? What would that transformation result?
It was a shift upwards.
Right. So if I go plus 1,
Translation.
I've translated the function vertically by unit of 1. Okay, so I'm into that. So that's f. That's f of x plus 1. Nicely done. Nicely done. Nicely done. So there's our f of x plus 1 right there. Okay. So with that, what's another transformation? What's another thing we need to do to part or all of f of x? Yeah, Miranda.
Subtract pi over 2 from x.
Ooh, interesting, interesting, interesting. Why subtract, as Miranda says, pi over 2 from x? So I've got f of x minus pi over 2. What's this going to do?
It aligns the dip to 0 actually at the origin.
Right.
It shifts the graph to the right.
Shifts the graph to the right. Yes, it aligns the minimum at 0. It shifts the graph to the right by pi over 2 units. I love it. So let's make that happen. So sine, and it's an inside change, right? So the sine of x minus pi over 2. Nice. All right, we're getting closer. We're getting closer. I'm so into this. Okay, nice. What else do we need to do? Allegra's table. Not that it's her table in the possessive, but U4. What was a transformation that you guys also did back there?
Multiplied by 250.
Multiplied what by 250?
Everything.
The whole thing by 250. Why would you do that? I'm asking anybody back there. Why do 250 times the whole f of x?
Like anyone?
Anybody? Why multiply by 250?
You want the apex of sine of x in this case is 2. So you want 2 to equal 500. So to multiply the whole thing by 250, the apex equals 500.
Right, we want that to go to 250. We want this, 500. We want this to go to 250. In fact, we want every y value to be scaled by a factor of 250. Okay? So now, let's see here.
I think it's
Yes, you can.
I mean, this is perfect. This is where we did it. But like in retrospect, it's easier to think about if you say first we multiply it by 500 and then we divide it all by 2 because having pi divided by 2 becomes pi divided by 10, but like by 250 is kind of like doing it backwards and that kind of.
Right. It's the same thing. I think.
It's the same thing, just like logically.
Yeah. I think either way is fine. But again, here we are. We've scaled it vertically. I've changed the axes so that we can see it a little bit more plainly. But this is where we've arrived at right now, right? We've got right? We've got this whole thing right here, and it's darn close, right? We're 0, 0 here. We've got the vertical. We found, right, that sort of center line is at about 250. What's the last transformation that we need to perform here? What's the last, or maybe there are more, but what else should we do to our function here? There's like one more thing that needs doing. Yeah, Sam?
Well, we should scale it horizontally so that one full rotation happens every 30 minutes.
I love it. Scale horizontally, Sam says, so that one full rotation or period happens every 20 minutes, rather than what? Rather than every 2 pi. So right now, our period right here is just, that is just 2 pi. We want it to go to 20 minutes, right? 20, really. We want it to go from 2 pi to 20. So how, Sam, would you suggest making that transformation?
Well, since we're trying to stretch it by a certain amount, we figure out what the ratio is between what would we multiply 2 pi by to get it to 20?
So I like it. So 2 pi times some ratio, we'll call it b, equals 20.
Yeah, and so then we can divide both sides by 2 pi.
So b equals 20 over 2 pi equals 10 over pi.
Yes. So then our scaling factor, or our stretching factor, is 10 over pi. And so we want to stretch the graph by that much. And so in order to do a stretch, we have to divide x by that.
Right? Remember, it's a horizontal stretch. So if we want to scale by a factor of 10 over pi, we actually divide by 10 over pi, or love it, or multiply by the reciprocal of 10 over pi, which is pi over 10. So theoretically now we should have f, or the new f of x, so we'll call g of x should equal 250 times sine of pi over 10x minus pi over 2 plus 250. Let's see how that worked.
Go over the 1 to 9 and say diagonally.
That would be pretty great. So we multiplied what by pi over 10, right? So pi over 10. There's our Ferris wheel. Nice job. Nice job. Something that's key to remember here. Don't back up. Just hang on for just 30 seconds here, gang. Thank you for your patience. The key thing to remember here is all we do, right, when we're working with more complex transformations of trig equations, okay, all we're doing is applying the exact same inside-outside changes that we know from existing functions to our sine, cosine, tangent, other functions here, okay? They're just harder, but you know what? We'll actually find out that they're exactly the same. So, very nicely done.